This right here is a more detailed version of the parent function y equals a log base b of x. I'm already including the vertical stretch or compression of a. I didn't really draw it including a reflection, but hopefully we all know how a vertical reflection would impact this graph. This over here is 1 over your base. So if your base were 3, this would be a 1/3. This over here is 1, which is your x-intercept as long as it's in this form. And this over here is whatever your base is over your base. Then here, we usually would go up or down 1 unit unless there's a stretch or compression. In that case, we go up or down 1 times a. So if that were a 5, we'd go up 5 for this point right here. And if this were a 5, we would go -5 for this point right here. If you'd like a more simple way to look at the parent function, not including the stretch or compressions, you could look at it as follows. Here again we have the parent function without the a value included, so if that helps you out a little bit, you could think of it this way instead. There's still a vertical asymptote at the y-axis or at x equals 0, and our x-intercept is 1 unit away from this vertical asymptote. Then we move over whatever the base is and up 1. You don't need to include this point. You really could pretend it's not there. If it bothers you, you don't even need to think about it at all. Those 2 points are really enough. So if you don't want to include that point, you don't have to. Then we just apply transformations the same way we've been applying transformations on every other function. A times log base b of b x minus h plus k. We can move this graph left, right, up or down. You can stretch it, compress it, or reflect it both vertically and horizontally. And you may want to think of this as your other dotted line, dashed line, that we use to move our graph all over our coordinate plane. So the 2 dotted lines will help you move your graph. They intersect at the coordinate point of hk. The equation of your vertical line is x equals h. The equation of the yellow dashed line to help us draw it is always y equals k. This is always y equals k. That is always x equals h. This is always 1 unit away unless there's a b there. So then it's times the reciprocal of b, since b is your horizontal stretch or compression. That's that distance always out there. This distance here works the same way. 1 over b times the base. This distance in between there is always a. This distance is also a in size, except we go down. So if you wanted to put negative, you can do that as well. Here we're asked to graph the following function. Then we need to find the domain, range, and the equation of the asymptote. I'm going to start off by analyzing the x plus 3. X plus 3 tells me that my graph is going to move 3 units to the left. That's going to be the equation of my vertical asymptote. So the equation of the vertical asymptote is x equals -3. I can go ahead and write that over here already. Next, I'll draw in another dashed line. This time, I'm going to draw in the dashed line at y equals -4. My graph had moved down 4 units. A horizontal line will always have an equation y equals. I'm going to do this my cheap way, where I go in and draw my dashed lines first, and then I draw my x and y afterwards. This is not an asymptote. This is just there to guide me as I draw my function. I have a base of 5, and I have a vertical stretch of 2. Normally I would go over 1 and up none from this crosshair. I don't have a horizontal stretch and compression, so I could still go over 1, up none, because 2, a vertical stretch of 2 on 0 is still 0. Next, I'd go over the base, 1, 2, 3, 4, 5. Go over the base, and then I'd go up A. So if I go from here, the crosshair, 1, 2, 3, 4, and 5, I would go up normally 1, but there's a stretch of 2, so I go up 2 units. And then if you really want the third point, you would go over the reciprocal of the base, 1 over B, which is 1/5, down 1 times 2 because of that stretch, so down 2. That gives me these 3 points, and I'm going to draw in my logarithmic function. From here, I'm going to go and draw my x and y axes based on the transformations I made. This was to the left 3, so my y-axis will be right 3 units. This was down 4, so my x-axis will be up 4 units. So there's my x-axis. That's my y-axis. The domain of this function goes from left to right, like all functions, and my graph does not start until the right side of my vertical asymptote. That means my domain is with a parenthesis, -3, comma, infinity, from -3 until infinity. Now the range, it's really important that you draw an arrow pointing down. This could look like a square root function if you don't pay attention. So this exponential inverse, which is log, this logarithmic function, which is the inverse of an exponential function, has a range of all real numbers, -infinity to infinity. This should make sense for our domain and range, since when we began learning about logarithms, we introduced them as the inverse of exponentials. And when you find an inverse, you switch your x and y's, your inputs and outputs, which will switch your domain and range. In an exponential, the domain was all real numbers, and its range was limited above or below the horizontal asymptote. For this next portion, we're going to graph the 3 given examples. First, we are going to do y equals -4 log base 10 of x plus 2 minus 3. Then y equals the ln of 1/3 x plus 1. And then last, y equals log base 3 of negative quantity x plus 2. This graph here has a base of 10, don't forget. X plus 2 moves the graph 2 units to the left, 3 units down because of that -3. In either case, I'm going to just start off by drawing dashed lines, one horizontal and one vertical. I'm going to start off by drawing a vertical dashed line and a horizontal dashed line, and that will be true of all of these examples. Here, there's a base 10. So, over 1, up none, back to the crosshair, over the base of 10, so it's already 1, 9 more, 3, gives me 4, 5, 6, 7, 9, 10. Now normally I would go up 1. The negative was a vertical reflection, and the 4 was a vertical stretch. So instead of going down 1, I'm going to go down 4 units. Really, these 2 points are all you need to draw your logarithmic function. From here, I'm going to draw in my x and y axes working backwards. Since this was left 2 units, my y-axis will be 2 units to the right of the vertical asymptote. Since this here moves my graph 3 units down, that means the x-axis has to be 3 units above. I'll label the important numbers. The domain for this function is going to go from -2 until infinity. The range for this function is -infinity to infinity. The vertical asymptote has an equation, x equals -2. Again, I'll start with 2 dashed lines. I'm going to start off by my typical over 1, up none. However, the 1/3 shows me I have a horizontal stretch of 3, so that means I'll go over 3, up none. Now, back to this point, And we normally go over the base and up 1. Out front, I don't have a vertical stretch or compression, so I definitely will go up or down 1. What is the base for natural log? The base for natural log is e, which is approximately 2.718, a little bit less than 3. If I'm stretching that by 3, well, 3 times 3 is about 9, so it'll be a little less than 9 units away. I'm just approximating, so I'm going over about 8.5 and up 1 unit. That gives me this distance here is 3, and this distance here is e times 3. I'll draw my logarithmic function. There was no horizontal shift. We didn't move left or right. That means my x-axis stays in the same place as the parent function. When this happens, I try to draw my vertical asymptote using a color or a highlighter so it's thicker and I can actually see it. We moved up 1 unit. That makes my x-axis 1 unit below this dashed line. Again, this could be 3e because I didn't move left or right, makes it pretty easy. This is 3. In the our domain for this function, 0 to infinity, the range, as it is for all logarithmic functions, is all real numbers, and the vertical asymptote is at x equals 0. The negative is going to be a horizontal reflection, so instead of our graph having a shape like this, our graph will have a shape like this. We normally go over 1 and up none. There's no horizontal stretch or compression. The negative just told us instead of going to the right 1 and up none, we're going left 1, up none. Next, we normally go over the base and up 1. My base is 3 in this example. This tells me I'm going to the left 3 and up 1. There's no vertical stretch or compression in this example for us to worry about. It's really enough information for us to draw a sketch of our logarithmic function. From here, we're going to draw the x and y axes. X plus 2 moves the graph 2 units to the left. That means the y-axis is 2 units that way. So that's our y-axis right there. Next, there's no vertical shift. That means our x-axis is right there. Our domain is a little bit different than the other examples. It's from negative infinity until infinity. Our range is always the same for logarithmic functions, negative infinity until infinity. Our vertical asymptote will be at x equals -2, which I will also label in this picture.